Hi, welcome back to Year 12 Maths and Mechanics, and well done for doing the two questions that I set last lesson, which was questions 6b and 7b, and well done for understanding that. What I'm going to do today is I'm going to do the harder questions from exercise 10c. So this is part 2, exercise 10c, that's the heading in your book. And I'm first of all going to look at example 7 on page 163. So have that book opened up, please. Have a look at what it says in example 7. I'm going to do a sketch of the diagram for you now. So it says a body of mass 5 kilograms, so a body of mass 5 kilograms, just going to do that by a box, is pulled along a rough horizontal table. So this is my table that the mass is resting on. I'm going to pull it this way, and it says that the pull force is 20 newtons. Now, because the table is rough, we've got a rough table, there is a frictional force, and it tells you in the question that the frictional force is 4 newtons. It says, given that the body is initially at rest, so we could say when T is nothing, U is nothing, it's initially at rest. It says find the acceleration of this body here. Now it's being pulled this way, so the acceleration will be along here. And because it's this force is constant and this is constant, my acceleration will be constant. So because my acceleration is constant, I know that I can use SUVAT for this question. Right, so to begin with, question 1 asks me to find the acceleration of this particle. Well, I know that my equation of motion is F equals ma. I'm going to resolve horizontally in this direction because that's the direction of the acceleration. So, resolving horizontally, this is exactly what you were doing last lesson. I've got 20 newtons going to the right, and I've got 4 going the other way. So, minus 4 equals the mass times the acceleration. So, I just simplify this. 16 equals 5a. So A will be 16 over 5, which works out to be 3.2 meters per second squared. Okay, part B. So part B asks to find the distance travelled by the body in the first 4 seconds. So I'm just going to put my diagram up like this, so we can still see the diagram. We now know the acceleration A, we've worked that out, so we know the acceleration is constant and it's 3.2 meters per second squared. Right, remember I said this is a constant acceleration, hence we can use SUVAT. So let's look at what we've got. So I'm going to write my SUVAT down here. And this is part B that I'm now doing. So you're asked to find the distance. You're told initial velocity is 0. We're not told about the final velocity, so I'm not going to use that. We know the constant acceleration going in this way is 3.2. And it says that we want to find the distance travelled in the first 4 seconds. So we're told T is 4. So you need to now look at your SUVAT equations, which we did in chapter 9. And we want the equation that does not involve V. So which one does not involve V? Well, I can see it's this one here. So that's the equation I'm going to use. I'm just going to write that down. Always tell the examiner, and you are given these on the formula sheet. And then you just sub all of this into here, and you will get S to be 25.6 meters. Okay, that's part B. And then part C asks to find the magnitude of the normal reaction between the body and the table. Well, from the first exercise A and B of this chapter 10, when you look at a body, this will have a downwards force of the weight, which is 5g, and it will have an upwards direction, which we call the normal reaction. We're going to call that R. Now, because this is not moving up or down, it's only moving across the table, it's not moving up or down, then R must be equal to 5g because there is no motion up and down. So for part C, my R must be equal to my 5g. G is just equal to 9.8. So if I work that out, I will get 49 newtons. The normal reaction between the body and the table. So that was the example 7 in the book on page 163. So let's look at now 2 more questions. So the next one I'm going to look at is, if you turn please to question 11 in the book. So question 11 states, if I just find it in the book, question 11 on page 165. So I'm just going to draw the diagram from this. If you just have a read of it first, please, for question 11. So it says, you have an engine of a van of mass 400 kilograms. So I'm just going to draw my van here, mass 400 kilograms. Cuts out when it's moving along a straight horizontal road with speed 16. The van comes to rest without the brakes being applied. In a model of the situation, it's assumed that the van is subject to a resistive force. So if it's moving, if I'm going to say it's accelerating this way, and I'm going to say the resistive force, it tells you in the question, it's 200 newtons. So I've got no force going this way because the engine has switched off its brakes. Okay, if it hadn't switched off the brakes, there'll be a driving force. Now, it's going to eventually stop, so my acceleration will turn out to be negative and it will then stop. So, to work out, first of all, part A says find out how long it takes the van to stop. Well, before we can do that, again it's constant acceleration, we need to find A. Okay, so this is the suvat that I'm going to use once I've got A. So to find A, I know my equation of motion is F equals ma. So I'm resolving this way to the right. I know my force, I've got nothing here, and I've got minus 200 going the opposite way, equals the mass times the acceleration. So if you work this out, acceleration will be negative 0.5 meters per second squared. So let's look at now my suvat. What have I got here? So you're told an engine of the engine of a van is that mass. It's moving along straight horizontal road with a speed of 16. It comes to rest, okay, 0, and you want to find the time that it takes, this is what we're finding, the time it takes for it to come to rest. And we know the acceleration is -1/2. So we decide what SUVAT formula we're going to use. So we want to look at the one without S in it, because S is not involved. So we're using this first one here. So we have V equals U plus AT. If you put all of this into here, you will get T to be 32 seconds. Right, that was part A. Part B, find how far the van travels before it stops. So you're finding out S now. Now, because we've already worked out T, you can in fact use any one of these formulas to find S. Well, obviously it has to have S in it, so one of these formulas here. Now, I'm going to use actually the one without T in, just in case I worked out my T wrong. I know it is correct. So, the formula I'm going to use is this, the kinetic formula. I put all of my values in, and you will get S to be 256 meters. And question C says, comment on the suitability of the modelling assumption. Now, the modelling assumption is you've got your resistive force this way of 200 newtons. That might not be constant, there might be air resistance as well. Okay, and the last question I'm going to do now is question 9 from the same exercise. So just wait a minute, I'll just get some spare paper. Okay, so question 9. So what does 9 say? 9's about a lift. Okay, so if you get question 9 on page 165, have a quick read of that, pause the video while you're reading it. Right, you've got a lift of mass 500 and it has passengers that have a mass of 300. So the total mass, you've got your 500 plus your 300 is 800. The lift starts from rest and accelerates at a constant rate, reaching a speed of 3 after moving a distance of 5 meters. And first of all, it says find the acceleration of the lift. Okay, so I've got the weight of this lift going downwards. Depending on what the tension is in the lift here, depending on whether it's going up or down, and we're going to look at part B and C working out this tension, the lift might be accelerating downwards or upwards. Okay, so part A, to use SUVAT, we are going to find the acceleration. So you're told it starts from rest and it reaches a speed of 3. We want to find A, time is not involved, and it reaches the final velocity of 3 after moving a distance of 5 meters. So which of my SUVAT equations shall I use? So I want the one without time in, so I'm going to use this one here. So I'm going to put everything into here and I will find A to be 0.9 meters per second squared. And this is the last question I'm going through, but a really important one for you to listen to. Right, part B. It says find the tension in the cable if the lift is moving downwards. Okay, so let's put our acceleration going downwards. and we've worked it out to be 0.9, whether it's going up or down. So, part B. So I'm going to use F equals MA for part B, and I'm resolving vertically this way, downwards. So I've got a positive force down, a negative force up, the tension in the lift, equals my mass times my acceleration. And if I work all of that out, I will find the tension to be this much, 7,120. Okay, now let's imagine it was now going the other way. So let's look at my new diagram. So I've got 800, start off with a clean sheet here I think. We've got 800 kilograms. I've got 800 G going down. I'm now going upwards, so my direction of motion of the acceleration is 0.9. So I'm going to use F equals MA, but I'm going to resolve upwards. So this time tension is positive, my weight is negative, the mass is 800 and the acceleration is 0.9. So now if I work out my tension, I will get 8,560 newtons. So if we're going upwards, we have more tension pulling it up, because we have to think about the weight of more of the weight of the lift going up than if it was going down, because the weight is helping it go down. Because the tension when going down was much less than the tension in the lift going up. Okay, so that's all my examples for you. I'm only setting you 2 questions to do. 2 compulsory questions, 8 and 10 please, from 10C. And for those of you who are feeling really confident in this, please have a go. I'd love to see your questions on this. The challenge question 10C. Please, please, please email me of any questions you have. It is getting very complicated now, and I really want you to understand this before we move on to the next section. Have a good day.